Hi all. In this video we're going to take a look at an example solution to a problem that appeared in the University of Waterloo's 2024 Senior Canadian Computing Competition. We'll first go through the problem description together. We'll then outline an algorithm that can be used to solve the problem using sets. We'll then step through the algorithm at a high level for an example string. After that, we'll take a look at a Python implementation of the algorithm. We'll then take a look at how sets can be implemented in C using bits in an integer type value to determine membership of elements. And we'll finish off with an example implementation in C. So here is the problem statement taken verbatim from the contest. In a string containing only lowercase letters of the alphabet, A through Z, we say a letter is heavy if it appears more than once in the string and light otherwise. We will be given a number of strings. For each string, we would like to determine whether the letters of the string alternate between light and heavy. Here is the input specification, also taken verbatim from the contest, along with one of the example data files. Let's go through the specification now. The first line of input will consist of two positive integers t and n, representing the number of strings and the length of each string. The next t lines each contain a sequence of n lowercase letters of the alphabet. So if you haven't tried this problem, why not pause the video now, try it out, and then hit play again when you're ready to continue. The algorithm we'll be using in this video is shown here. We basically create two sets of characters, one to keep track of characters that appear in a string, and the other to keep track of characters that appear more than once, which the problem defines as heavy. We then go through each character in the string. We check whether the character is in the set seen. If so, it means we've encountered the character at least once before, so we add it to the set heavy. Otherwise, we mark it as encountered by adding it to the set seen. After that, we go through the characters a second time. By now we know which characters are considered heavy. We simply check whether they are in the set we called heavy, and we're able to check whether the characters alternate between heavy and light. The nice thing about sets is that lookups, that is checking whether elements are in a set, are very fast. Instead of performing a sequential search through an array of data, for example, some property of the element being searched for is used to identify where in the memory the element would be located if it were in the set, so we can check whether it's there very quickly. Alright, let's take a look at how the algorithm works on an example string. Here we have two empty sets, seen and heavy. One of the example strings that appears in the contest problem is ABCB, so let's use that here. The first character in the string is A. We check whether A is in the seen set. It's not, so we simply add it to seen. The next character is B. It's also not in seen, so we add it to seen. Similarly, the next character is C. We check whether C is in seen. It's not, so we add it to seen. The last character is B. As before, we check whether it's in seen. This time it is in seen, so instead of adding it to seen, we add it to heavy. Of course, if we add an element to a set that already contains that element, the set does not change. So in this case, if B is already in heavy, it doesn't matter if we add it again. We're now ready to go through the string a second time to determine which characters are heavy and which are light. For this, we simply check whether each character is in the heavy set. The first character A is not in heavy, so it's considered light. The second character is in heavy, so it's considered heavy. Similarly, C is considered light, and B, as we've already seen, is considered heavy. So for this example, the characters did indeed alternate between heavy and light. So let's take a look at a Python solution that follows this algorithm directly. We first read in the number of lines of text and the width of the string in each line from the first line of the problem input file. If you remember, the first line comprises two integer values separated by a space. So here we split the input line on white space and convert the results to integers. We're then ready to read in the strings. The first step is to create two empty sets, which can be done in Python like this. We then read in the string from the problem input file. We're then going to go through each character in the string. For each character, we check if the character is in the set seen. If it is, it means we've encountered the character at least once already, so we add the character to the set heavy. If not, we add it to seen to mark it as encountered. Now that we know which characters are considered heavy, we are ready to check whether the characters alternate between heavy and light. Here we save whether the first character in the string is considered heavy into a Boolean variable isHeavy. We then start looking at the rest of the characters, in other words, the characters starting at position 1. The problem description actually asserts that the strings are at least of length 2, so we don't need to worry about index 1 being out of bounds. Here we save whether the character we are looking at next is considered heavy into a Boolean variable nextIsHeavy. If its heaviness, so to speak, is the same as that of the previous character, then we know that the string does not perfectly alternate between the heavy and light characters, so we can output the result F. We don't even need to look at the string any further, so we can break out of the for loop as well. If we're still in the loop, we update the value of isHeavy to nextIsHeavy so that we're ready to perform the same comparison with the next character. In Python, we can follow a for loop with an else block, which we only reach if the for loop completes. In other words, if a break statement was never encountered. In that case, it means that the string did perfectly alternate between heavy and light characters. And so we output the result T. And we're done. Next, let's take a look at an example of a solution to this problem in the C language. Before we do so, however, let's spend a little time thinking about how we can implement sets in C. One way is to use the bits of an integer type value to mark elements as either being in a set or not. To illustrate this, let's work with a nibble of data. In other words, an integer type with only 4 bits. This could be used to represent a set with up to 4 elements. To create an empty set, we simply set the value of the nibble to 0 so that all the bits are switched off. Now let's say that we want to add the element associated with the bit at position 2 to the set. We take the number 1, which of course is 2 to the power of 0. We then left shift it twice. And we then perform a bitwise OR operation on the set data. Now the bit at position 2 is switched on, which we can interpret as meaning that the element associated with this bit belongs to the set. Let's add another element. How about the element associated with the bit at position 0? Again, we start with the value 1. This time we left shifted 0 positions. In other words, the value stays the same. We then perform the bitwise OR operation. And now we have a set with 2 bits switched on, which we can interpret as containing the 2 respective elements. What about checking whether elements are in the set? For example, say we want to check whether the element associated with the bit at position 2 is in the set. Again, we start with the value 1. left shift it 2 places, but this time we perform the bitwise AND operation on the set data. If the bitwise AND is greater than 0, then it means that the element associated with bit 2 is in the set. Let's check whether a different element is in the set. How about checking whether the element associated with the bit at position 3 is in the set? We start with 1, left shift it 3 positions, perform the bitwise AND, and in this case the result is equal to 0, which means that the element associated with the bit at position 3 is not in the set. So that's alright, but how do we associate letters that can appear in this problem's strings to bits in an integer type variable? Well, notice that there are only 26 characters, that is, the letters A to Z, that are possible in this problem. This means that we only really need to use bit positions 0 to 25. A 32-bit integer type, for example, is more than enough for this use case. What we could do is associate each possible character with a bit position equal to its offset from character A. For example, the offset of character A from character A is 0, so we could associate element A with the bit at position 0. The offset of B from A is 1, so we could associate element B with the bit at position 1. Similarly, the offset of C is 2, so we could associate element C with the bit at position 2, and so on. So let's take a look at how we could work with the example string we considered earlier, ABCB. To check whether character A is in the scene set, we start with 1 and left shift it 0 places. We can now use the bitwise AND to check if A is in set scene. In this case it's not, so we can use the bitwise OR to add it to scene. The next character is B, which has offset 1 from A. So we start with 1, left shift it 1 position, use bitwise AND to check if it is in scene. It's not, so we use bitwise OR to add it to scene. The next character is C, with an offset of 2. We take 1, left shift it twice, use bitwise AND to check if it is in scene. It's not, so we use bitwise OR to add it to scene. The next character is B with offset 1. We take 1 and left shift it 1 position, use bitwise AND to check if it is in scene. In this case it is, so we use bitwise OR to add it to heavy. And now we know which characters are considered heavy and light, and we're ready to check whether the characters alternate between the two states. Okay, so let's take a look at an example C implementation of this. Let's include standard I/O for input and output, and standard lib since we're going to allocate enough memory to store each line. Here we define a type we've called set. Notice it is simply an unsigned integer. Here we've defined how to add a character to a set. We get the offset of the character from A, left shift 1 that many positions, and then perform the bitwise OR operation on the value of the set and update the set with this value. Similarly, here we define how to check whether a character is in a set. We find the character's offset from A, left shift 1 this many positions, perform the bitwise AND operation on the value in the set, and check whether the result is greater than 0. And that's it. Now we're ready to use sets. So here we're in main. Let's create variables to hold the number of lines and the width of the string in each line. Here is a character pointer we'll use in a moment to allocate enough memory to hold a string, and a character dummy that we'll use to read the characters one by one. Here we read in the two integers in the first line of the problem input file. Now that we know what the width of the strings will be, we can allocate enough memory to hold a string. And we're ready to start going through the lines. Here we create two empty sets. Remember that set is just another name for an unsigned integer in this context. Setting a set to 0 is equivalent to switching all the bits off. Here we read the characters from the input file one by one. For each character, we check whether the scene set contains the character. If so, it means we have already encountered the character at least once, so we add the character to the heavy set. Otherwise, we mark the character as encountered by adding it to the scene set. Here, we save the character to the allocated memory so that we can go through the string a second time in a moment to see whether the characters alternate between heavy and light. We mustn't forget that at the end of each line there is a new line character. Here we just scan in a character to flush the new line. And now we know which characters are considered heavy, and we're ready to check whether the characters alternate between heavy and light. Here we use a variable called isHeavy to store whether the first character in the string is considered heavy, and a variable called index that we'll use to index the characters in the allocated memory. So we've already looked at the first character in the string, so we can start indexing from position 1, where the second character of the string is. Here we record whether the next encountered character is heavy in a variable called nextIsHeavy. If its heaviness is the same as that of the previous character, then we know that the characters do not perfectly alternate, so we can output the result f and break out of the for loop. If, after that, we're still in the for loop, then we update the value of isHeavy to reflect that of nextIsHeavy so that we're ready to make the same comparison with the next character. Once we're out of the for loop, if the value of index is the same as that of width, it means we did not break out of the for loop, in which case the characters must perfectly alternate between heavy and light, so we can output the result t. And that's pretty much it. Of course, it's a good habit to free the memory we allocated. And we're done. So I hope you enjoyed the video. There are actually many ways we could have solved this particular problem. If you used a strategy that is completely different from that presented in this video, be sure to share in a comment below.